Section 210.52C3 of the National Electrical Code, or NEC, specifies the maximum number of branch circuits permitted on a single 15 or 20 amp overcurrent protection device, either a circuit breaker or a fuse for general purpose branch circuits. A maximum of 12 branch circuits are permitted on a 15 amp overcurrent protection device. A maximum of 20 branch circuits are permitted on a 20 amp overcurrent protection device. There is an exception. This limit can be exceeded if the overcurrent protection device is dedicated to a single load, such as an air conditioner or a range. Overcurrent protection devices are designed to trip and interrupt the flow of electricity when the current exceeds a safe level. The NEC limits the number of branch circuits on a single overcurrent protection device to prevent overloading and the risk of electrical fires. If a residence has a 20 amp circuit breaker protecting a group of receptacles in a bedroom, no more than 20 branch circuits can be connected to that circuit breaker. If a dedicated circuit is installed for a refrigerator, a 15 amp circuit breaker can be used, even though it allows a maximum of 12 branch circuits. The actual number of circuits permitted on an overcurrent protection device may be further limited by the ampacity of the wiring used. The total load on an overcurrent protection device should not exceed 80% of its rated amperage. It is recommended to have a licensed electrician evaluate your electrical system to ensure compliance with the NEC and safety standards. Branch circuits are an essential part of any electrical system, distributing power from the main panel to various points throughout a building. Understanding how many circuits can be safely connected to a single overcurrent protection device is crucial for preventing electrical hazards. The NEC provides guidelines to ensure safety and prevent overloading. Section 210.52C3 specifically addresses this issue for 15 amp and 20 amp circuits, which are common in residential settings. For a 15 amp overcurrent protection device, the NEC limits the number of branch circuits to a maximum of 12. This means that a single 15 amp circuit breaker or fuse should not supply more than 12 individual circuits. This limitation is in place to prevent the total load on the device from exceeding its capacity, which could lead to overheating and potentially cause a fire. Similarly, for a 20 amp overcurrent protection device, the NEC allows a maximum of 20 branch circuits. This higher limit reflects the greater capacity of the 20 amp device to handle more load. Again, the purpose is to ensure that the total load remains within safe limits, preventing overloads and potential hazards. The NEC recognizes that there are situations where these limits may not be appropriate. One common exception is when the overcurrent protection device is dedicated to a single load. This means that the circuit breaker or fuse only supplies power to one specific appliance or piece of equipment. Examples of dedicated loads include air conditioners, electric ranges, and large appliances that require their own circuits. In these cases, the NEC allows the number of branch circuits to exceed the standard limits. For instance, a dedicated circuit for an air conditioner might use a 20 amp circuit breaker even if it only supplies power to that one appliance. This is because the load is known and controlled, reducing the risk of overloading the circuit. To illustrate how these rules apply in practice, consider a typical residential setting. If a house has a 20 amp circuit breaker protecting a group of receptacles in a bedroom, no more than 20 branch circuits can be connected to that circuit breaker. This means that the total number of outlets, lights, and other devices powered by that circuit should not exceed 20. If a dedicated circuit is installed for a refrigerator, a 15 amp circuit breaker can be used, even though it allows a maximum of 12 branch circuits. This is because the refrigerator is the only load on that circuit, and its power consumption is within the 15 amp limit. It's important to note that the actual number of circuits permitted on an overcurrent protection device may be further limited by the ampacity of the wiring used. Ampacity refers to the current carrying capacity of a wire, which is determined by its size and insulation type. The NEC provides tables that specify the ampacity of different types of wires under various conditions. The total load on an overcurrent protection device should not exceed 80% of its rated amperage. This is a safety margin that helps to prevent overheating and potential hazards. For example, a 20 amp circuit breaker should not be loaded with more than 16 amps of continuous load. To ensure compliance with the NEC and maintain electrical safety, it is highly recommended to have a licensed electrician evaluate your electrical system. A qualified electrician can assess your wiring, circuit breakers, and other components to identify any potential problems or violations of the code. They can also provide recommendations for upgrades or repairs to improve the safety and efficiency of your electrical system. Firstly, understanding the principles of overcurrent protection is crucial for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. This excessive current can be caused by a variety of factors, including short circuits, ground faults, and overloads. When an overcurrent occurs, the protection device trips or blows, interrupting the flow of electricity and preventing damage to the wiring and equipment. Secondly, circuit breakers are resettable devices that can be used repeatedly. They contain a bimetallic strip or an electromagnet that responds to excessive current. When the current exceeds the rated value, the strip bends or the electromagnet trips, opening the circuit. Fuses, on the other hand, are one-time use devices that contain a metal element that melts when subjected to excessive current. Once a fuse blows, it must be replaced with a new one of the same rating. Thirdly, the NEC specifies the requirements for overcurrent protection devices to ensure that they are properly sized and installed. Section 240 covers the general requirements for overcurrent protection, including the types of devices permitted, the methods of installation, and the coordination of protection devices. Section 210.52 provides specific requirements for overcurrent protection of branch circuits, including the maximum allowable current and the types of devices permitted. Fourthly, when selecting an overcurrent protection device, it is important to consider the ampacity of the wiring and the load that the circuit will be supplying. The overcurrent protection device should be sized to protect the wiring from overheating, but it should also be large enough to handle the normal load without tripping unnecessarily. The NEC provides tables that specify the ampacity of different types of wires under various conditions. Fifthly, the NEC also specifies the requirements for the location and accessibility of overcurrent protection devices. Section 240.24 requires that overcurrent protection devices be readily accessible, which means that they should be located in a place where they can be easily reached without the need for tools or ladders. The devices should also be protected from physical damage and environmental conditions that could affect their performance. Sixthly, in addition to the general requirements for overcurrent protection, the NEC also provides specific requirements for different types of circuits and equipment. For example, Section 430 covers the requirements for motor circuits, which are often subject to high inrush currents during starting. Section 625 covers the requirements for electric vehicle charging systems, which require special overcurrent protection to prevent hazards. Seventhly, it is important to understand the difference between branch circuits and feeders. Branch circuits are the circuits that supply power to individual outlets, lights, and appliances. Feeders are the circuits that supply power to branch circuits from the main panel. Feeders typically have higher ampacities than branch circuits and require different types of overcurrent protection. Eighthly, the NEC also provides requirements for ground fault circuit interrupters, or GFCIs, which are designed to protect people from electric shock. GFCIs detect small imbalances in the current flowing through circuits and quickly interrupt the power, preventing a potentially fatal shock. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas where there is a higher risk of electric shock. Ninthly, arc fault circuit interrupters, or AFCIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby materials. AFCIs detect the unique characteristics of arcing faults and quickly interrupt the power, preventing a fire from starting. AFCIs are required in certain locations, such as bedrooms, living rooms, and hallways, where there is a higher risk of arcing faults. Tenthly, the NEC is constantly evolving to keep up with new technologies and safety concerns. It is important to stay up to date with the latest changes to the code to ensure that your electrical system is safe and compliant. The NEC is typically updated every 3 years, and it is available for purchase from the National Fire Protection Association, or NFPA. The proper installation and maintenance of electrical systems are crucial for preventing electrical hazards and ensuring the safety of occupants. Overcurrent protection is a fundamental aspect of electrical safety, and the NEC provides detailed guidelines to ensure that these devices are properly sized, installed, and maintained. By following the NEC and consulting with a qualified electrician, you can help to protect your home or business from electrical fires and shocks. Overloading an electrical circuit occurs when you draw more current than the circuit is designed to handle. This can happen when you plug too many appliances or devices into a single circuit, or when you use appliances that draw a lot of power, such as hair dryers or space heaters. When a circuit is overloaded, the wires can overheat, which can damage the insulation and potentially cause a fire. Circuit breakers and fuses are designed to protect against overloads by tripping or blowing when the current exceeds the rated value. However, if the overcurrent protection device is not properly sized or if it is defective, it may not trip or blow in time to prevent damage. It is important to understand the signs of an overloaded circuit so that you can take steps to prevent it. Some common signs of an overloaded circuit include flickering lights, warm outlets or switches, and tripped circuit breakers or blown fuses. If you notice any of these signs, you should immediately reduce the load on the circuit by unplugging some appliances or devices. You should also have a qualified electrician inspect the circuit to determine if there are any underlying problems. Short circuits occur when there is an unintended connection between two conductors in the circuit. This can happen when the insulation on a wire is damaged or when a foreign object comes into contact with the conductors. When a short circuit occurs, the current flows through the unintended path, bypassing the load and causing a sudden surge of current. This surge of current can quickly overheat the wires and cause a fire. Circuit breakers and fuses are designed to protect against short circuits by tripping or blowing almost instantaneously when the current exceeds the rated value. However, if the overcurrent protection device is not properly sized or if it is defective, it may not trip or blow in time to prevent damage. Ground faults occur when there is an unintended connection between a conductor and ground. This can happen when the insulation on a wire is damaged or when a foreign object comes into contact with the conductor and ground. When a ground fault occurs, the current flows through the unintended path, bypassing the load and potentially causing electric shock. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults by detecting small imbalances in the current flowing through a circuit and quickly interrupting the power. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. Electrical fires can be caused by a variety of factors, including overloaded circuits, short circuits, ground faults, and defective wiring. These fires can be extremely dangerous, as they can spread quickly and produce toxic fumes. It is important to take steps to prevent electrical fires by following safe electrical practices and having your electrical system inspected regularly by a qualified electrician. Some simple steps you can take to prevent electrical fires include avoiding overloading circuits, using appliances with the proper wattage, and replacing damaged or frayed cords. You should also have smoke detectors installed in your home or business and test them regularly to ensure that they are working properly. Electrical codes are a set of rules and regulations that govern the safe installation and maintenance of electrical systems. These codes are designed to protect people and property from electrical hazards, such as fires and shocks. The most widely used electrical code in the United States is the National Electrical Code, or NEC, which is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to keep up with new technologies and safety concerns. It is important to follow the electrical codes when installing or modifying electrical systems to ensure that they are safe and compliant. Licensed electricians are trained and qualified to install and maintain electrical systems in accordance with the electrical codes. Hiring a licensed electrician is the best way to ensure that you electrical work is done safely and correctly. Licensed electricians have the knowledge and experience to identify potential hazards and to install electrical systems that meet all applicable codes. They can also provide valuable advice on how to improve the safety and efficiency of your electrical system. Electrical safety is everyone's responsibility. By understanding the basics of electricity and following safe electrical practices, you can help to prevent electrical hazards and ensure the safety of yourself and others. Always be aware of the potential dangers of electricity and take the necessary precautions to protect yourself. If you are not comfortable working with electricity, always hire a licensed electrician to do the work for you. Remember that electricity can be dangerous if it is not handled properly. Always be careful when working with electricity and follow all safety precautions. By taking the necessary steps to prevent electrical hazards, you can help to protect yourself and others from harm. Maintaining your electrical system is crucial for ensuring its safety and reliability. Regular inspections and maintenance can help to identify potential problems before they become serious hazards. Some common maintenance tasks include checking for loose connections, replacing damaged or frayed wires, and testing circuit breakers and GFCIs. It is also important to keep your electrical panel clean and free of debris. Dust and dirt can accumulate on the components and cause them to overheat, which can lead to a fire. It is recommended to have your electrical system inspected by a qualified electrician at least every 3 years. An electrician can identify any potential problems and provide recommendations for repairs or upgrades. Electrical emergencies can occur at any time and can be extremely dangerous. It is important to know what to do in an electrical emergency to protect yourself and others. If you experience an electrical emergency, such as a fire or shock, immediately call 911. Do not attempt to put out an electrical fire with water, as water can conduct electricity and increase the risk of shock. Instead, use a fire extinguisher that is rated for electrical fires. If someone is being shocked, do not touch them directly. Use a non-conductive object, such as a wooden broom handle, to separate the person from the source of electricity. Once the person is free from the source of electricity, call 911 and provide first aid until help arrives. Electrical systems are complex and can be dangerous if they are not handled properly. It is important to have a basic understanding of how electrical systems work and to follow safe electrical practices. However, it is always best to hire a licensed electrician to do any electrical work that you are not comfortable doing yourself. A licensed electrician has the knowledge and experience to ensure that the work is done safely and correctly. By following these tips, you can help to ensure the safety and reliability of your electrical system and protect yourself and others from electrical hazards. Never attempt to repair or modify electrical equipment unless you are qualified to do so. Electrical work can be dangerous, and it is always best to leave it to the professionals. If you are not sure how to do something safely, ask a licensed electrician for help. Always turn off the power before working on any electrical equipment. This will help to prevent electric shock. Use caution when working near water. Water conducts electricity, so it is important to keep electrical equipment away from water sources. Never overload electrical outlets or circuits. Overloading can cause the wires to overheat and start a fire. Use extension cords sparingly. Extension cords can be a fire hazard if they are not used properly. Inspect extension cords regularly for damage and replace them if they are worn or frayed. Keep electrical cords out of high traffic areas. This will help to prevent them from being damaged. Protect electrical outlets and cords from children. Children can be injured by playing with electrical equipment. Install tamper-resistant outlets in homes with young children. Use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock. GFCIs can help to prevent serious injuries. Have your electrical system inspected regularly by a qualified electrician. An electrician can identify potential hazards and make recommendations for repairs or upgrades. By following these safety tips, you can help to prevent electrical accidents and injuries. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before undertaking any electrical work.